Okay, so let's talk about first the congruence of right triangles, and then we'll get into overlapping. So here's the hypotenuse leg theorem. This was on the puzzle, Edpuzzle. You need to have a right triangle first. So if you need to define right angles, you need to do that first, okay? And when we say hypotenuse leg, it means they could have done NL and RQ, but MN and QP have to be there, okay? The leg is kind of versatile. You could pick either one. Sometimes you're not going to be able to use HL even with a right triangle. It might be a side angle side, just disguised, okay? But just keep in mind that, hypotenuse, definitely, the leg, and the hypotenuse is always across from the right angle. Always, 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 okay? So what information is needed in order to apply hypotenuse leg to this theorem? Well, if we look, we see that this has 5, so we would need, in this case, MN to equal 5, and we would need, let's see, it looks like PR to equal 9. That's pretty much it. That's all we're looking for, okay? Because we're looking for that congruency. Obviously, these are measures, so what would we apply here in order to get to congruency? Who can remind me? If I wanted to state that, LN is congruent to PR, what would I have to put here? Because we're in measures. Right now we're saying, let's say LN is equal to PR. And we want to get to here. How would we do that? Yeah.
Definition of congruent segments.
Yeah, definition of congruent segments. Okay? So that's a big one, actually, to kind of transfer back and forth. That's why we're just reviewing it. So this is on page 100. We are skipping one. Is there any questions on this before I move on with anything? Now let's get into a proof. So it says, write a proof to show that two triangles are congruent. So my first step is I'm going to have my statements and my reasons. Now I'm just going to save some space, but you guys know all of this gets put right into there, right? I'm just saving some space right now, because sometimes this can get a little clogged. Okay. So now that we know that JL is perpendicular to KM, we also know that JK is congruent to KL. They want us to prove that JKM is congruent to LKM, okay? Well, if that is the case, I'm just gonna grab a different color here. First thing I'm gonna work with is this whole idea of this perpendicular stuff, okay? So that means I'm going to state that KNL, so angle KNL and angle KNJ are right angles. And that would be by the definition of perpendicular lines. You can just write it like that, definition of perpendicular, the upside down T, okay? And because those are right angles, I can state that they're what? Congruent. Yep. Yep, exactly. So I state that angle KNL is congruent to angle KNJ by the right angle congruence theorem. So now it's okay if you want to, you can kind of mark them kind of like that if you wanted to do it that way. But it's totally up to you. That is not necessary. If you want to label them both right, that's fine too. It doesn't matter, okay? All right, step 4. I am now going to say that KN is congruent to itself. Reasoning? Good. Very good. Reflexive property. And now if I look at this, I know we're trying to go for the larger triangle here, but we don't have enough to do that yet, so we're going to prove these two triangles congruent right now, okay? So step 5 here is going to be that triangle, I think I have it listed as, let's see, KNJ is congruent to triangle KNL. And this is by HL. Everybody with me so far? You guys okay? Okay. Okay. So that takes care of those two smaller triangles, but remember, we're trying to get these larger ones, so we need more parts, okay? So the first thing I'm going to do is I'm going to go back to this whole idea of, now, I'm going to give you a warning, or actually just more of a realization. You are not going to have anything this complicated on your test, okay? You won't, I promise. You will have proofs, but they're not going to be like this. Otherwise, that'd be the whole test, okay? However, this goes over a lot of really good rules, so that's why I'm doing it this way, okay? I'm sure there's other ways to do it, but this has a lot of good review in it, okay? All right, so looking at this next one, we're going to state that, I'm going to go back to this whole idea of these perpendicular lines, okay? So step 6 in this case, I'm going to state that JNM is a right angle and LNM are also right angles, okay? So here we have angle JNM and, whoops, sorry, angle LNM are right angles. And that's by the same thing as here, definition of perpendicular, because we know they're perpendicular lines. Okay? Now, step 7, I'm going to state that JN JN is going to be congruent to NL. What would be the reasoning for that? Why could I state that without really doing much? Yeah.
EM is a bisector. It's a segment bisector, right?
It is.
So
That's one way, yeah. So we could say definition of, that is definitely one way. I was thinking of something else, but that's okay. I like it. Oh, wait, it doesn't say it's a bisector. It just says perpendicular. It doesn't say bisector. So there's another way.
Is it, so those two angles are equivalent. Those hypotenuse and circumference.
Not definition of midpoint. We don't have any proof that it's a midpoint. But we did prove two triangles congruent. So which means what? Yeah, it's CPCTC. Very good. Congruent parts of congruent triangles are congruent. So if we wanted to define n as a midpoint, or that km is a perpendicular bisector, absolutely we could. Do you guys see how that kind of works? Okay. All right, so we have that. Now the next thing is, I'm kind of jumping around here because my fault, I kind of forgot that part. Should have done up here. Now for part 8, I'm going to state that these two are congruent to each other. J and M are congruent to angle LNM. And that's, again, by the right angle congruence theorem. Oops. So we're kind of repeating a lot of different little steps here. And but you guys notice how I like, oops, I forgot this. Why don't I add it in? Can I do that? Absolutely. Okay? Just make sure you're not losing track. It's still valid because all of this is coming after we prove these triangles congruent. Okay? Okay, now that I know I have this information, I'm just going to kind of mark this. So we have that's congruent with that. We have, this angle is right also along with that angle. What else do we need here? And we know, wait, how did we? Jan, how does it switch to that? We got a right angle. J and M. We don't have a hypotenuse yet. Oh, okay. So our next step is to do NM is congruent to itself. Okay? And that's going to be by reflexive property. Now we can state these two are congruent, but it's not HL this time, it's what? It's side angle side. Do you guys see the difference? That's another reason I really like this proof. He deserves a high five for that. Don't leave him hanging. Okay, so now we're going to do part 10. This is a lot longer than I had expected also. Is that triangle. Ooh. Come on now, don't do that. JNM is congruent to triangle LNM by side angle side. Whew, this is a lot, isn't it? And now we can state without a doubt, like all of these parts are kind of congruent. We can kind of pick what we want, right? So now we have, okay, well, if those two are congruent, let's just state that, okay, let's state this is congruent to this, okay? By CPCTC, so let's do JM is congruent to ML by CPCTC. And then because we're working on this whole idea, we can state next that KM is congruent to itself by reflexive. And then we have that the two triangles are in fact congruent. So then I'm not even going to write that down because they're, ooh, what the heck? Sorry. I'm not even going to write that down. We just know that that is the last step, okay? Did I spell something somewhere? Lots of info. Again, not on the test, but it does review things very, very well. Okay? And, oh, I'm sorry, these two triangles would be congruent by side, side, side. I didn't even think about that. Ran a little bit out of space, though. Sorry. Any questions that I can address for you guys? Sorry. Don't get overwhelmed. Remember, this is a review. It has HL, it has side angle side, it's got side, side, side. All of these things just to visualize and to check out, okay? You're not going to have anything that's complicated on your test. I promise. If you were, believe me, I would not be this laid back about it. Questions, though? All right, we're going to move on to 4-6. Is anybody writing? Because I have to erase it. Okay, so in this case, if we look at try it 1, it's saying, what are the corresponding sides and angles of triangle FHJ and H and KHG? You have options here, okay? Your best bet, this is considered an overlapping triangles problem, okay? Your best bet is to draw these out. So here is my first one, okay? So I'm physically just going to draw that. So I have F, I have H, I have J, and here is my second one. So here I have G, I have H, and then I have K. Now the hardest part about overlapping triangles is that you have to remember that they, like everything that is here still applies, okay? So, oh, that is not what I want to do. Sorry, let me redraw. New system, I'm just starting to get the hang of it. H, K. And then we have G, H, K. That's supposed to be a J. Oops, sorry. There we go. Okay. So we still need to apply all of these markings that we have here. So we are stating that F is congruent with K. So that's not changing. We can also see here that if we look, F and J have the same kind of tick marks as K through G, right? Now, we're not formally proving that, but we can state that this is congruent with that, most definitely. Okay? Now here's the other thing I'm going to bring to your attention, because this is where you're going to see the other side of this property. H is in both of these, so I can state that H is congruent to H. What property would that be?
Reflexive.
That's your other side of reflexive property. It's not just for sides, okay? So if we wanted to list all of these corresponding parts, and just kind of like a row, okay, I would state that FH would be congruent to HK. Those would be the corresponding sides. You would also have HJ is congruent to HG. You also have FJ. Would help if I could actually write a J. Sorry about that. Would be congruent with KG. And then for the angles, you'd have angle F is congruent to angle K, which we already identified. You'd have angle H would be congruent to itself. By that reflexive property, and you have angle J is congruent to angle G. Okay? So those are all the corresponding parts with all the congruency statements. All right? Does that make sense? Now, in the end, if you want to draw them out as two separate triangles, you can. You don't have to, though. It's just a tip. Okay? Whatever works for you works for me. Anybody still writing this down? All right, so we are looking at our first proof. This says angle WVZ is congruent to YZV. So WVZ is congruent to YZV. It's already marked. And they're also saying that WVY is congruent to YZW. Now, I know in your book it says something else. We're going to formally prove it though, okay? So we're going to prove that VW is congruent to ZY, okay? So, obviously our first step, per usual, is let's create that area with our statements and our reasons. Step one is that all of this goes into here, and that is given to us. Now step two, if we take a look at this, I'm just saying, let's see, something tells me I'm going to have to go to, from congruence to measures, because I'm seeing that I have these two parts right here, and I'm going to have to determine something else there, okay? That might help. So I'm going to state that the measure of angle WVY is equal to the measure of angle YZW, and I'm going to state that the measure of angle WZV is equal to the measure of YVZ. Who can tell me the reasoning? Go ahead. Very good. So this is the def of congruent angles. All right, part three. Now that I know that those are together, I can state that this plus this equals the entire thing. And I can state this plus this equals the entire thing. So I'm going to have that the measure of angle, I have this written, WVZ is equal to the measure of WVY plus the measure of YVZ. And then I'm also going to state that the measure of angle YZV is equal to the measure of angle YZW. I'm sorry, YW. Sorry, YW. No, Z was correct. YZW plus the measure of angle WZV. What's the reasoning behind that? What did I add? What did I put here? This is a topic 1. Yeah.
Angle addition postulate?
Very good. Angle addition postulate. All right, I don't know what that was, but part 4. Okay. Now, if we take a look at this, we can see that, remember, we have these things that are already equal to each other, right? So we can replace some of them in order to get what we need. So in this case, what I am saying here is that I substituted the measure of WVZ is equal to the measure of YZW plus the measure of WZV. So I did that to substitute in so that they match, okay? But you could have chosen either one. It didn't it won't matter. But this is substitution property. Now, if we look, WVZ, I pretty much replaced this, like right here. And now this matches this. Did you guys see that? Okay. So that means, let me just scoot this over. I'm not a fan of this slider. Part 5 is going to be that this angle now equals this angle. Okay? So I'm going to have the measure of angle WVZ is equal to the measure of angle YZV. And then again, that's by substitution property. I'm just going to put little quotes there. Same thing, just different step. Okay? Now that I know that these are equal, what can I state? They're what? Congruent. So I'm going to have angle WVZ providing it works is congruent to angle YVZ or YZV, sorry. I just put a little line here. And that's going to be by the definition of congruent angles. Part 7, now we just did this. We just said, hey, this little piece right here is congruent to that little piece right there. Okay? And that actually helps. Now our next part is going to be that VZ is congruent to itself by what? Reflexive. So then VZ is congruent to VZ, and that's going to be reflexive property. Okay, so now that I have these little corner angles for each, I know that these longer angles are also congruent, right? And I have this side. I can say both triangles are congruent. How? What criteria? So just to kind of recap, let me get a different color. So we have this little guy, this little guy, and we have these entire angles too, along with this whole side. So if I split this up, again, which is another option for you, just remember that. Okay, and this is Z, Y, V, and I have this next triangle here, which is Z, V, W, okay? And we just found out that this is congruent to this. We know this is congruent to that. And we know this entire part is congruent to this entire part. Do you guys see how splitting them up can kind of help? I know it's kind of a drag. Do you guys see that a little bit better now? So how are these two triangles congruent? Yeah.
Angle, side, angle.
Angle, side, angle. So I'm going to state that triangle VW ZV is congruent to triangle, because remember that concurrence criteria still counts. We got to be careful with how we write this. YVZ, okay? And it's going to be angle, side, angle. And then our last step, now we have those two triangles congruent, but they wanted to prove that VW and ZY are congruent. What are we going to apply here? Yeah.
CP.
Exactly. So VW is congruent to ZY, that'd be by CPCTC. I know your minds are a little blown right now. I get it. I see the smoke. How we're not triggering the alarms, I don't know. But what questions can I answer or address? Yes.
Wait, like, what was the reason for number 5?
The reason for number 5, okay, so you understand what I did in 4, right? Or are you just talking about this part?
Yeah.
Oh, it's just substitution property. I was running out of space, so I just put quotes. Does that make sense? Yeah, that's just a substitution property again. Any other questions? Does it make somewhat sense? Like, is it like one of these things where, probably just need to practice it a little bit? Okay. Who wants another proof, though? I have another. I have it planned. It's actually a lot shorter than these. Like, I mean a lot. Lot. Like, an insane amount shorter. So if you want me to, I can do 3 real quick, and 3 actually mimics your test a little bit better. You want to do it? Okay. Okay. Is anybody ready? Because I don't want to clear this until you guys are ready. Okay, so again, this one, again, we have these 2 overlapping triangles. And what I'm going to do is I'm going to split them right away so you guys can kind of see how that works, okay? But you still have this original picture to work with too, which is nice. So let me draw these. So they're talking about, write a proof to show that triangle SRV is congruent to TUW. All right, so here's what I'm going to do. I'm going to give you the givens because they wanted you guys to figure that out on your own. So we're not going to do that. So given, I want you guys to write that down. We're going to say SR, I mean, you probably could have, but why bother? We can make this easier on ourselves. Is congruent to TU. You have angle SRW and angle TSV are right angles. That looks hideous. I'll just write it out. Okay, and then and remember, just put this somewhere, kind of maybe in the blue area would be best, but if you put it in the white, that's okay too. Then we have angle STW is congruent to angle TSV, and we're going to prove that triangle SRV is congruent to triangle TUW, okay? I am going to erase this, so I want you guys to write it down. We are not doing 4, so if you want to continue this into the area of 4, that's fine, okay? But again, I don't want to move on until everyone's got this information down first. Who is still writing? Okay. How we doing? Caught up? Anybody still writing? Okay. I am clearing it though. All right, so again, let's create those lovely little 2 columns. There's my statements, there's my reasons. Step 1 is your given information. Now on your test, you're going to have to write it in. I'm not going to, all right? It's just too much space. Okay. Now, if we look at this, again, there's a lot going on here, right? This is a very complicated little picture. You can split them up. But honestly, looking at this, I'm going to have to use probably a little bit more additional information here than I originally thought. But that's okay. So I'm going to leave it as is, and we can split it up towards the end like we did. Okay? So the first thing I'm going to do is that I'm going to right off the bat state, because this is just going to make my life a little easier, that angle SRW is congruent to angle TSV. What's my reasoning for that? Why did I state right off the bat that they're congruent? Like, why? Based off the givens. Yeah. They're both right angles. So this is the right angle congruence theorem, right? Now, I stated that those are congruent mainly because if I look at this, do I have anything here that's going to help me get TW or SV? Is there anything there where I can apply HL? No. So I'm not going to bother. Okay? I'm going to move on to side angle side. Or something else. Or maybe angle side. It all depends. Right? All right. Now because of that, the other thing I know is that for part 3, I'm going to have that ST is congruent to ST. Why?
Reflexive.
Mm-hmm. So looking at this, these are the 2 triangles that I right now have information on. Do you guys see that? I have an angle. I have another angle. And I have that corresponding side that works with both. So part 4 is going to be that triangle WST is congruent to triangle VTS. And that's going to be by a reflexive property. Oh my gosh, why did I say? I'm sorry, it is not reflexive. OMG. What? Sorry, guys. Angle, side. That's better. Oh my gosh. Can't believe I said reflexive. Sorry about that. Okay. So now that I have these two triangles, I know that their parts are going to be congruent now. Now I have something that I can prove these two triangles that I absolutely need are congruent. Okay? So you all had that, right? Okay, just checking. So now that I know that those two triangles are congruent, now I can talk about the parts. And now I have something I can use HL with. Okay? So for part 6 in this case, okay? Now remember, we proved this triangle and this triangle congruent, so I'm going to talk about SV being congruent to TW, okay? And that is going to be by what? Who can tell me? Just, ooh, I don't know why I did that. Yeah, very good.
Also,
Yeah.
what was step 5? Because I have 4.
Oh, whoops, I just put the wrong number down. Sorry about that. This is step 5. Sorry. There we go. I just misnumbered. All right, so now that I know that those two are congruent, do I have enough information to apply HL here? I do. So now I can state that triangle SRV is congruent to triangle TUW, and this will be by HL. And if we look, there's our leg. There's our two hypotenuses or hypoteni. I don't know. Hypotenuses. I don't know. All right, that prove that these two work. So the deal with overlapping triangles is this. Sometimes you got to look at what you're given, and you might not be able to go straight to the triangle you want to prove. But this is why we have CPCTC, right? To get those parts that we need. So if I'm just going to erase this. Is anybody still writing this down before I do? So if I looked at this, I can see, you guys see this triangle right here and right here? I see I have those two angles, bam, I have that extra side, I'm good, right? So I probably didn't need to add that these two are equal to each other because it didn't do any good anyway. And that's okay. If I did that, it's just kind of like, it's just information that you don't need. You won't necessarily lose points, just don't overdo it. Does that make sense? And then in this case, if I look, if these are the two triangles I'm proving, well, I have a right angle here. 1 or 2, that automatically determines that I'm either going to have side angle side or I'm going to have HL. There's not going to be anything else. And your best bet, and if I looked at this even a little bit closer, I see, ooh, that's a side of this one I can solve. Then I know I can apply CPCTC and be done. Okay? Sometimes working backwards to get your plan and then moving forwards is the best idea. But looking at the triangles themselves, like, what's in common? What can I use to actually get to where I need to be? Okay? Questions? And again, splitting up the triangles is fine too. You would just have to split it up twice here. Okay? Just for the originals that you got, and then doing the HL part. Are there any questions I can address? Or is this just like, oh my gosh, this is so much, I just need to work, like, to get my head around it? Homework is on Savas tonight. And it does go through like proofs. It'll give you like part and then you do the other part. So hopefully that'll help with the visualization. I will give you more proofs, like paper proofs, when we come back. Okay? Sound good? Okay. Have at it then. Those of you watching at home, have a great day.